Network automation is pretty difficult when you're working with traditional network configuration tools like the Cisco IOS Command Line Interface, or CLI. Now, it has the ability to run some TCL or TCL scripts to automate some tasks, but generally it's considered very difficult. Network automation is also pretty difficult using SNMP, or Simple Network Management Protocol. Although you have the ability to do remote network configurations, and it's excellent for monitoring the network, to push configurations to end devices and work with SNMP is generally considered to be labor-intensive and difficult. Network automation today is developing rapidly thanks to networks moving to the cloud and the advent of virtualization. Today we have RESTful APIs and configuration management tools that can help to automate network configuration and other network tasks. Configuration management tools like Ansible, Puppet, Chef, and SaltStack. These configuration management tools typically use Python or Ruby. Ansible uses Python and YAML, whereas Puppet and Chef use Ruby and SaltStack uses Python. These management tools use recipes to script changes and automate changes over the network. Ansible uses playbooks, Puppet uses manifests, Chef uses cookbooks, and SaltStack uses pillars. This is an example of an Ansible playbook that I got from DevNet at developer.cisco.com. You can see that it has plays. Here we can see two plays. One, we're going to report host name and operating system details, and the second play, report network details of servers. The hosts are set up in the host file, and those define the actual IP address or domain names of the devices. For tasks, we have on the first play two tasks: get the host name from the server and then get the operating system. In the second play, we have three tasks. We want to find out what the default IPv4 interface is. We want to retrieve the network routes using a netstack command. We're going to put that information into a variable and then show that information with the network routes installed. To see the results of these tasks, we're going to use the debug modules, and modules can also use parameters. In this case, we're going to be using the message parameters. Lastly, we have the variables. The variables are surrounded by double curly braces. Now you can retrieve variables that are built in. These are facts within the system. Or you could set your own variables. In this case, we're registering a variable called routes right here, and then we're going to use that variable in the message parameter. In the debug module with the message parameter, we'll call that route variable. Let's take a look at this in action. I'm using CentOS 7 as my developer workstation. I'm going to cat out the example1.yaml file and take a look at our playbook. This is the same playbook we looked at in the slide deck. I'll clear the screen, and then I'm going to run the command ansible-playbook, put in the -user parameter for my username developer, and I'm going to run example1.yaml, and this should use Ansible to connect over to the DevNet sandbox and connect into the DevOps computer that I want to configure using my Ansible playbook. Okay, you can see that the play is running. Report host name and operating system details. Task 1, it's gathering the facts. All right, task 1, get the host name from the server. There it is, message devbox. And task 2, operating system. And there's the message returned, CentOS. Now for the second play in the playbook, report network details of servers. Okay, the default IPv4 interface and the message returned, there it is, ENS 160. The next task is to retrieve the network routes. Okay, we got a response. Looks like this playbook worked perfectly. You can see the reply back right here. These are the network routes installed. You can see it ran the netstack command with a argument of -rn for the route and the numbers. And you can see there is the routing table on the device.